So we have another wonderful guest with us here at We Don't Have Time at COP29 in Azerbaijan. It's Bram Maasakers. Correct that for me. How would you say it?
It's Maasakers, but I think that was close enough.
Maasakers, okay. And he's a senior scientist at SRON, which is the Netherlands Institute for Space Research.
Right.
Wonderful to see you. Thank you for being here.
Thank you.
So tell us about your work on methane and carbon monoxide data at the Institute. What's happening?
Right, so at SRON we're working on analyzing satellite data of methane. So we're analyzing data from satellites that circle around the Earth and observe how much methane is present in the atmosphere. Mm-hmm. And with some very recent developments, we can also use that to detect plumes from individual emitters. So specifically for methane, that's a great opportunity because we can find the largest leaks, for example, in the oil and gas industry, and also estimate emissions from large waste disposal sites such as landfills.
Right. So methane satellites have become the vogue at the moment. We've got Methane Sat with the Environmental Defence Fund and many partners, New Zealand Space Agency. Which satellite are you using?
We're using a combination of satellites.
Okay.
So we are using the Tropomi instrument, which is on an ESA satellite. That gives us a global picture every single day. Mm-hmm. And then we're using additional satellites, such as GHESat, but also things like Sentinel-2, to really zoom in at specific facilities. Mm-hmm. Because some of these satellites can zoom in at a resolution of like 25 meters. So then the individual observations cover an area of 25 by 25 meters. So you can see exactly where the emissions are coming from.
Interesting. And where then you look at it, you get the data, you process the data in a way that humans can understand it. And where does it go after that? What do you do with the data?
Right, so going through the data is a big step, right? Because we have all these millions of observations. So we use a lot of analysis techniques to really get the information out there where we have these big emitters. And then the next step is trying to reduce those emissions. So for example, for the oil and gas sector, we're sharing the detections and the analysis that we do with IMEO, the International Methane Emissions Observatory. Mm-hmm. That's a program under the United Nations. And they are then communicating that information to the relevant governments and companies to try to get those leaks mitigated, because that's a pretty complicated playing field with all these different countries and companies. Mm-hmm. So that's not where our expertise as scientists is.
Right. Right.
In addition to that, we're really trying to push the work on waste. Waste has also been one of the central topics here at the COP. Mm-hmm. And we have a project with the Global Methane Hub where we're working together with cities in the Global South to see how can we use these data to support mitigation actions. Now, sometimes that can be kind of like leak detection, but it can also be helping in establishing what are emissions and can we track those emissions as mitigation plans are implemented.
Yeah. So, that's really very helpful, especially that the developing world are also getting information. I suppose the question then is, there comes a moment at which you would, as a scientist working hard on this, get to a point where you anticipate that those countries and companies indeed react to it. So there comes a moment where you start seeing declines or leaks stopping, or people are starting to divert organic waste away from waste tips so that you start seeing those plumes reducing. Mm-hmm. Are you seeing any of that yet? Or when do you hope to see some of this? And therefore by inference, when can the public, do you hope, expect action on methane to reduce those emissions of this superheating gas? Yeah.
Right, so I think we've seen examples of this working. So for example, IMEO has shown examples where they've notified a company and then the next time the satellite looks at it, the leak is mitigated. I think in general, there's still a ways to go in getting that response rate up higher so that more companies are doing that. For the waste sector, it's a little bit of a long-term plan, right? Because it takes a while to implement those measures and it will require a lot of partners like NGOs and local governments to come together to work on that. I hope that there's some momentum on that. And I really think for the oil and gas industry as well, we really need to speed up those reductions, because if you think about the global methane pledge, a commitment to reduce global methane emissions by 30% by 2030. 2030 is not that far away anymore, right?
No.
So we really need to see that next push
Yes.
in using all that satellite that we generated to actually get emissions down.
Yes. And also the International Energy Agency has been talking about that the oil and gas sector industry could, or they should, maybe reduce by 75% quickly, but at no extra cost if they want to do it. So it could be a win-win for them, and also people might start loving them a little bit more, and be a win-win for the scientific research and obviously for the public and the future of this planet. So it's a really critical time, the work you're doing, and also now getting that response from the sectors concerned. Yeah.
Yeah, so indeed I think it would be really good to see those emissions that we can detect go down. Having said that, we won't detect everything as a plume from space because we are pretty far away, so it's also a matter of reducing the smaller sources.
Yeah.
And in terms of loving the industry, I don't think reducing methane emissions should be an excuse to delay moving away from fossil fuels.
Exactly.
Because really we need to be reducing methane emissions and CO2 emissions in parallel.
Yeah. Yeah, the new British climate minister, Ed Miliband, said the other day that methane is a sprint, but CO2 is the marathon. So we have to be running both races. Yeah, exactly.
Yeah.
Just briefly then, with the time left, carbon monoxide, why should we be interested in that?
Yeah, so carbon monoxide is emitted when combustion isn't fully efficient. So we see that from a number of industrial sources that we're tracking. We also see it from fires. And fires are an important thing to keep track of because it's one of these things that may also change with a changing climate. It's the same with some natural sources of methane, like wetlands. So there we really want to track what is happening with those emissions to see where we're going in terms of emissions and how climate is changing that.
Right. So the carbon monoxide is incomplete combustion by industrial processes, so they need to be more efficient about how they burn things, so you get less carbon monoxide. And also in forest fires, carbon monoxide is released.
Yeah.
And so that allows you, you can see forest fires in space from the heat, can't you?
Yeah.
But you see something different with the carbon monoxide.
Yeah, so you also start to see what are the emissions from those fires.
Right, okay.
And we see that they can have a big impact also on CO2.
Yeah.
And CO2 is one of the areas where the satellite data are also quickly improving, so we can directly measure CO2.
Okay.
So really we're at the start of like a wave of new data. As you mentioned, MethaneSat was launched, Carbon Mapper launched a satellite.
Yeah.
We're getting a lot more eyes in the sky to look at these sources and then hopefully support mitigation actions.
And finally, when we look at these sources, now with more precise satellite telemetry and are we seeing actually that we have more of these gases than we thought in general?
So I think starting to look at these sources, for example, in the oil and gas sector from space, we're seeing a lot of these large emission events that we weren't necessarily expecting.
Right.
So that is really bringing additional layer of transparency to where those emissions are happening. So that can then also help us to focus our mitigation efforts.
Right.
So yeah, we're learning a lot about those emissions.
And
but
you take doubt out of it as well, because the industry can say one thing, somebody can say something else, somebody can say something else, but when you've got this kind of more precise science, nobody can really, they can dispute a few percentage points here and there, but in the end, everybody's got the same data, right?
yeah, I think exactly for methane, which is like an invisible and odorless gas, making it visible through seeing those satellite observations, seeing a plume coming off one of these facilities, that has really helped to also make people see the problem.
Yeah, super. All right, well, thank you very much indeed for being with us. It's very important work. With 5 years to go to halve emissions, we need to have the best possible data and the best possible action that humanity can muster to actually get us back on track and hand over a functioning planet to the next generation. So thank you very much indeed.
Thank you.
Okay.